Now, with all of this, how virtual commissioning can help on that, right? So to answer this question, we have prepared four scenarios that actually have happened in our customers. We extract that, the core things, and put all together these four videos that I'm gonna show you. So I just want to mention here, like the video, this is not real confidential customer data, so we will not show our customer data, but it's based on all derived from the real world project. So, and that happens a lot. All right, let's take a look at the first one. The first one I'm gonna show you is, a pretty straightforward one, right? So we are connecting your PLC, drive the model in Process Simulate, and you're seeing here we are using the virtual HMI to test to see if our production line is working well or not. There's one thing I would like you to pay attention. Look at the bottom part of your screen. This is the time scale. The time scale. I can control the time in the virtual world. I can let my devices go 10 times faster of what is normally in the physical world. So we see customer, just because of this, the time scale capability, they kind of compress the commissioning work from 5 days to 1 day, 5 to 1 day. Okay, so with this, you can quickly cycle through your logic, right, and see from a high level what could be the problem in your production line, in your automation cell, or whatever the other project you are working on. So in this particular example, we find there may be something wrong with the manual operation of the conveyor belt. So we zoom in a little bit. We want to take a closer look and see if we can find it. Okay, what I'm gonna do is I'm gonna start my operation. I'm gonna manually start my conveyor, generate a tray. It's moving here, and I'm trying to stop the conveyor. I'm trying to stop it manually. I click the button, it doesn't stop. Something is wrong. Then I go into the TIA portal right here. Some of you guys may already have used it a lot. So this is the automation PLC programming software that for Siemens. So what I'm gonna do, I make it online, right? Make it online so that you can see the real status of the signal, in this scenario. So you see here, we very fast we can identify what's the problem. So one of the logic here in network number 3, like the type of the signal, the type of the tag is actually wrong. We should set it to this kind of a set instead of the previous one. So we can make the change very quickly, and then we re-download it to our PLC. We go back to Process Simulate here. We're gonna rerun this to see if the problem actually gets solved. All right, generate the conveyor, generate the tree. Okay, so far so good. Let's click the stop, perfect. The problem is solved. It's a pretty straightforward kind of case, right? So let's go a little bit deeper. The second example, let's talk about safety. Safety in automation is a very, very important. I believe all of you guys are gonna agree on that. So you have to validate your safety design very, like in a very comprehensive way, right? Before you actually ship your line to your customer. So in this particular case, we're gonna do that. So the first thing I want to test is this e-stop button, right? I start my operation here, and I click the e-stop button. Okay, things works well here, so everything stops. That's good. Now we're gonna test the auto mode. What are we gonna do? We're gonna create a safety scenario that we're gonna force this door open, and we want to see if the operation got stopped. So that's what we want to test, all right? So we start the auto mode. We're gonna manually force the door open. Okay, everything just keeps going. So this is not something we want, right? Something is wrong in your safety logic. So we go into the TIA portal again, make it online, similar way. You monitor the status of your tag, all the signals here, and we can very quickly identify what's wrong with it. So here, in network number 2, we actually forgot to put the sensor that showing the status of the door into this logic. So we quickly add it down, and we re-download it to my PLC. After we finish all of this, we go back into Process Simulate, and we see if actually that fixed the problem. We start the operation, the robot start moving. Now, I'm gonna force the door open. So the beauty of doing these things in the virtual world is you can generate all kinds of safety scenarios, like without the concern of damage your devices, damage your equipment, or make somebody get injured, right? So you do whatever you want in the virtual world. So now I just force the door open, everything stopped. So I solve another problem. So this actually happened in our customer. So we just, well, it's pretty common validation of safety that you can do, right? So yeah, so that's what you can do on your safety side. Third one, let's go a little bit complicated. In this scenarios, I'm gonna bring in the robot. What I do here is I load the entire robot backup into Process Simulate. There is a robot here, it's a little bit on the corner, but I load the entire robot backup into Process Simulate. Process Simulate can recognize, all the robot program, I/O, the kind of all the frames. If you pay attention to the right side of the window here, this is showing the main program that the robot is running. And on the bottom right, this is my HMI panel. And on the back of the software, it is connected to a PLC, which is driving everything. You see here, we have robot, PLC, HMI all together in Process Simulate. Now let's take a look. So what I'm gonna do is, you see here, there is a tree. We have the part load here. Okay, and we activate the conveyor using the HMI. So click start, see, okay, the tree moved here to a certain position by design. So this robot should come over here to pick up the parts and put into the machine for further processing, but it's not. The robot doesn't move. What's going on, right? So if you pay attention to the right side of this screen, you see here there's small yellow arrows. So that is where your robot program stopped right there. So we can see what's going on. So the robot is waiting for a signal, input signal number 4. So for some reason, the robot doesn't receive the signal for some reason, or the signal status doesn't change. So what do? We go into the Robot Signal Explorer in Process Simulate. You see, this is the window, and we can quickly identify, we look into the input number 4 right here. So we see here the input number 4, and we see the PLC tag that associated with this robot signal right here, and we see the address is 15.1. So we're gonna search this address in our PLC and see what's going on. Again, I go back to TIA portal. I'm gonna search 15.1 right here, search the address right here to find where the tag is and what's happening for this specific signal. So very easily you can identify the tag, and I can cross-reference to find which network is using this particular tag. Okay, I click it. There we go. We got it right here. So this is network 13 is the one that's giving us some trouble, right? So this is the tag. We identified that, 15.1. And what are we gonna do? We're gonna see what's going on, right? So you probably know what we're gonna do. We're gonna put it online and see and redo the operation and see if there's anything, what's wrong with this one. So make it online. There we go. Everything is showing the live status based on the signal, the tags, everything is live. And we go back into the Process Simulate. Again, we're gonna using the HMI panel to start the simulation, all right? So again, when you're doing virtual commissioning, multiple screen is actually preferred, right? So, but we have to use one single screen for the demo purpose. Okay, I started, generate the tree. It's a bit smaller, but you can still see it. Load the part right here. Again, I'm gonna start the conveyor, and I'm gonna monitor the change of my signals in TIA portal right there. See here, one of one of the tag is blocking the signal to kind of a flow through to activate this 15.1, right? If you are a control guy, you probably immediately know what's going on, right? This one should be a normally closed kind of a tag instead of a normally open, right? This is a very common problem like you're gonna see during the commissioning phase. Like it's small, but sometimes it causes big problem. So we just quickly switch it to normally closed, and we're gonna re-download this program to the PLC. So what you see here, we have robot, PLC, HMI. So you can jump back and forth and cross-link within all three platforms and quickly identify what is going on, right? And again, combined with the previous, the time scale stuff, you can cycle through all of this code and you may change, in a faster kind of time scale so that you can quickly address the issue and validate if your change actually solved the problem. Now we just load it to the PLC, and we're gonna see if we actually solve it. Go back to Process Simulate right here. We're gonna rerun the simulation, do exactly the same thing, and see if it's actually solved the problem. Again, I go back to my HMI here, right down below, generate the first tree. This tree is supposed to be here, and waiting for the finished part, right? Very good. Second tree here, get the part loaded. Now it's the moment. Now we're gonna start activate the conveyor. The tree move over to here. To this position, you can see the robot actually come here to pick it up, right? And you can see, you can again see this yellow arrow here. This is the line the line of code the robot is running, right? So another thing I want to mention here is this is not only a viewer. The robot program viewer is not only a viewer, you can edit the program. If you want to do touch up of your robot program, you can do it in Process Simulate. And in terms of the robot brand, Process Simulate support all the major stream, vendors of robots on the market. You can load directly the program from whatever, like Robot Studio, ABB, Robot Studio, Robot Guy, whatever, KUKA SimPro, whatever, you load it to Process Simulate, you debug it, and you can touch up, you can make touch up. And the Process Simulate can actually export those, revise the program to the real robot controller so we can use it for production. Now, let's move into the very last example, the number 4. So in this particular scenarios, again, we are dealing with a robot. We want to change the end of arm 2 to another one. You see, this is the tool currently on the robot, and I want to switch it to this gripper. So the thing here is that gripper is, is being held by this clamp, right? The clamp, the release of this end of arm 2 is controlled by a PLC, external PLC. So that's the scenario. So we want to see if the coupling of the PLC actually working well with the kind of robot external kind of access, right? So let's take a look. Again, I'm gonna execute the tool changing program here from my HMI. I activate it, the robot is trying to change into, watch out, okay. It doesn't really couple correctly. So what if this happens in the real world? There are gonna be some damage to your devices, right? So this happened to our customer, like they got damaged, like they have to redo, they have to reorder the parts, right? So because sometimes the damage can happen anywhere during the commissioning process. So in this particular case, again, we go back to TIA portal. In this case, we are using the SCL, the structural control language, to handle the logic. I'm not sure how many of you are using it, but what I want to show here is Process Simulate and also TIA portal basically support this type of language full-blown, right? So I go online and then identify my problem. I need to add something into my code, and I'm gonna make the change, adding the code really quick so that so that the coupling of my PLC and robot signal can work correctly.
Real world scenario, that has happened. That's a common thing with the robot, right? It's going to change the end of arm tooling. You've got different parts coming in, but there's a dependency to the PLC. The PLC has an influence on you. When I first saw that, I was like, isn't the robot taking care of all of the end of arm tooling? For the most part, but the signal's controlling the release of the tool. So little things like that can end up cause you a lot of damage in time if you don't catch it, right, in time. So.
Well, it really depends. It really depends. In particular scenarios, there's maybe for this particular things you may not have, you cannot do the dry run. Very particular things. So case by case, right? So I know what you're talking about. Yeah, but it's really case by case. But this not only to apply to the kind of tool changing, right? It's like like I mentioned, damage is going to happen everywhere else. This is, you can imagine safety or whatever things, collision can happen anywhere. So if you just, sometimes that just happened to you, didn't expect. All the damage is not expected damage. It's just accident. All right, so that's the 4 cases, right? I'm gonna show you today. We got limited time. Pretty much we can draw the conclusion here, right? So what do you see here? The time scale, the control, the ability of control the time, the speed of time, so you can do things a lot faster. You can do things in parallel, of course, right? So all you need is provide another engineer with a computer loaded with Process Simulate, so they can work side by side at the same time. Yeah, and also you can. All of the uncertainty you're going to come across in the traditional commissioning, you can shift it to the early stage of your project timeline, right? So basically what we are trying to do here with virtual commissioning is we break down all those uncertainties, shift it left, right, to the early stage of your project so that you can work on it earlier. As long as you have something ready, you can test it in the virtual world without real equipment, so that you can solve a lot of the problems, small or big, in the very early stage before they bury too deep in your project, causing big problem at the very end, of the day. So we see many successful stories from our customer by using Process Simulate, using virtual commissioning, and we just pick 3 of them here. They have seen, improvement on different aspects here, right? So some of them have engineering time saved, programming time saved, or commissioning time. It really depends on what type of project you are working on. Different type project has different requirement at different stage. So that's pretty much give you an idea about how our customer is using it. These numbers are like the customer provide us the numbers. They do benchmark and they provide us a number from project. This is our real numbers, real safe.
The companies who are really taking advantage of this, the really smart ones, when those systems show up in the facility, first thing the real systems show up and the real systems are running, you betcha they're going out, they're doing their time studies and whatever real data they can pull off, and they go back and they calibrate the models. And those models then, you got a calibrated digital twin done, and they put it in their back pocket, and they go, thank you very much, Mr. Machine and Line Builder. You are building up the digital twin factory of the future for me.
Yeah. And another thing I want to mention here, one of the benefits actually, this is what our customer told me, right? So told us, right? So they win more business. So how? Because our customer love virtual commissioning, love seeing things before they actually being manufactured. So that completely changed the way of communication, the efficiency of communication. Many things, if you got a requirement change where you show the customer in a Teams meeting, share the screen, oh, I need to change that. Okay, no problem. It's still early stage. We can make the change and make everything just so much easier, right? So, and then customer, like they got more confidence, they win more business, right? So that's is what I'm seeing. We didn't expect that, but that's happening. All right, that's pretty much what I want to share today. There's one last comment I want to make for today is like the Process Simulate is actually a very, very powerful tool, right? Today, I just show you a small portion of Process Simulate, but actually this tool can do a lot more, right? If you want to learn more, right, so feel free to contact me or connect to me through this QR code from LinkedIn, and we can discuss more specific things. Thank you very much.